So let's write code for merge sort. Okay, perfect. So merge sort will get input just a list. I'm going to call it A, and we need to sort it. So the idea that we discussed, we'll first find the midpoint so that we can divide it into two parts. Okay, so I have a list, so the midpoint will be this. Let's just make sure that this is correct. So let's say if the array is of size 3, so 3 by 2, just 1 second, will be 1. So midpoint will be this one, which is fine. Let's say the length is 4, then 4 divided by 2 will basically be 2. So the indices are these. So this is what the midpoint you're getting, right? This is the midpoint that you're getting. So that's fine. I'm just going to make sure that I make equal copies. So I'm going to copy from 0 to mid minus 1 on one side and mid to the end on the other side. Okay, that's what I'm going to copy. Because if you're finding mid this way, this is what the mid is coming to be. So I'm going to make sure that I make equal copies. Let's take another example. Let's say I just have two numbers. So length will be 2. This will give me 1. So I need to make sure I make a split here, right? I need to make sure that I make a split here. So up to mid minus 1 will go on one side and starting from mid will go on the right side. Perfect. A1 is 0 to mid. When I say up to mid, it actually copies till mid minus 1. And A2 is equals to A starting from mid till the end. Right? So I have A1, I have A2. I'm going to call merge sort on A1. I'm going to call merge sort on A2. And both these will work fine because of induction hypothesis. Do not question this. Do not try to go inside as yet, because as soon as you try and go inside into recursion, things will get complicated for you because you haven't written the complete code. Because as soon as you write the complete code, things will be absolutely clear. For now, because this is a smaller problem, PMI tells you that this is induction hypothesis. Assume. Okay, please assume. Now, after you have sorted A1 and A2, I'm going to write another function merge, which is going to merge A1 and A2 into A, the original list that we had, and we'll be done. That's it. The two sorted lists that you have, you are merging them into the original array that you had, and that's what we were supposed to do. We were supposed to sort the original array. We don't have to create a new array. We wanted to sort the original array. Okay, so let me create this merge function, A1, A2, and A. So I need to merge A1, A2 into A. So as we discussed, I'm going to take I to be 0, j is equals to 0. I'm hoping you have written this code sometime earlier, so I'm going to be a little quick in this. So I is here, j is here, and as we discussed, we will go through both of these. So I can say while I less than length of A1 and j less than length of A2, while this is true, that I is within limit and j is within limit, as soon as you cross the limit, you can't compare. So you know that you are within the limit, so you can compare. So if A1I less than A2j, this basically means that one is smaller, right? So if the first one is smaller, that's the one you want to copy into the original one. So you have this bigger array, bigger list, you want to compare these two. This one is smaller, so you copy this one here. So I'm going to take another k, which is 0, and I'm going to use this as the index in the A list that we have. A1I, k is equals to k plus 1, I is equals to I plus 1. Because you have used A1I, you need to move I. Okay. If that's not true, in that case, I'm going to copy A2j, k will still move and j will also move. Right? Both of these will move. Okay. So what I've done here? So I'm saying compare these two, whichever is smaller, copy that. If you have copied this element, move I here. Then you compare this and this, and k is also moving. Whichever is smaller, you put that element here and you move that one further. So this while will finish as soon as one of these two arrays, one of these two lists are done, right? As soon as you complete this one, even if j is still here, this while loop will stop, because you don't have any more elements in the first list that you have. So you can't compare anymore. So you need to stop, but you're still not done. You don't have all the elements in the output array. So you need to copy rest of these to the end. Okay. You need to copy the rest of the elements to the end. How do we do it? So you can just run while I less than length of A1. In case I is done, this loop will not run. In case I is not done, that means j is done. So you need to copy elements from the first one. Okay, so what's going to happen? One of these will get over. The second one will be somewhere in the middle, right? It still will not be done yet. So it's very, very simple. I will run a loop on I, and I'll also run a loop on j. One of these loops will not run because the index is already to the end. It's already at the end. The other one will run, and I'll just copy all the elements to the output A that we have. So while I less than length of A1, I can copy this code, right? So I'm copying a1 I and I'm incrementing I and I'm incrementing k. I can write the same code for j, length of a2, and I can copy the code from here. And I think we are done. I'm assuming that the list that is passed to me has enough space. I'm not using append. I'm assuming this list has enough space, which is true in case of merge sort. In case of merge sort, you did a split on the original list and you made two lists from the first part and the second part. So there is enough space in the original list that you can merge the two parts into the original one. So I'm assuming there is enough space in A. Okay, that's why I'm not using append. I'm directly putting data into it. Okay, let's see if this will work. Comma 2. Sorry, I should take an unsorted one. And let's call merge sort on it. And let's print A after that. Okay. Okay. Seems like we made the perfect recursion error. We didn't write our base case in merge sort. So obviously we need to write our base case. If length of A is equal to 0 or length of A is equal to 1, I need to return. If the length is 0 or length is 1, I don't have to do anything, right? So I can just return. Let's run this again. Sorry. Let's run this again. And it's sorted now. Seems like it works. Okay, perfect. So most of the code was written here, but I think most of the interesting things were happening here, right? You decided that you want to split it into two halves, and then you decided that you want to merge them together. Okay, and amazing algorithm, works really, really well. Let's quickly dry run this to see how exactly it is working. So this was our input, right? So it's a 7 length input that we have given. So we found the middle. So we gave length was 7. 7 by 2 is 3. So 0, 1, 2, 3, right? So this is 3. So we took this part on one side and this part on the other side. So that basically means we created this and we also created this. Now we're going to call on the first part. Once the first part is done, then we'll call on the second part, right? The calls are in order. So first the call is on this one. So when you call on this one, it comes to the merge sort, and this again is not of length 0 or 1, so we are going to divide it further. So it will get divided into 10 and 5, 3. First call will be on 10. But 10 will say, hey, I am length 1, so it will return right away. 5, 3 will say, I'm not length 0, length 1. So it's going to further divide itself into 5 and 3. Make a call on 5, it will say I'm done. Make a call on 3, it will say I'm done. Then you have these two sorted lists with you, and you are going to merge these two into the original one. 5 is sorted, yes. 3 is sorted, yes. You're going to merge these, and the merged list will look something like this. So instead of 5, 3, it will become 3, 5. Then you merge 10 and 3, 5 into the original list here. So this will become 3, 5, 10. Similarly here, now when this is done, it's going to make a call on 1794. So we'll split it into two parts, 1, 7, 9, 4. 1, 7 is going to split it into two parts, 1, 7. 1 will say I am sorted, 7 will say I am sorted. We'll merge these two into 1, 7, it will stay the same. 9, 4, you will split it into 9, you will split it into 4. And you will merge these two and it will become 4, 9. This is sorted, this is sorted. You merge these two, this becomes 1, 4, 7, 9. So you made these two calls in the induction hypothesis and you can actually see that they become sorted. And when you merge these two into the original one, the original list becomes sorted. So that's how things are running and that's how things are working. You're breaking down the list into as small as one element lists, and then those are by default sorted. Then you are merging those one small ones into two, then those two becomes 3 or 4, and that's how smaller list combined gives you the original list, which now is sorted. Okay, so that's how things are working. I will definitely recommend you to dry run your code as well. Take a couple of examples, try to dry run and see how things are running. Okay, thank you.